Welcome to this lusas presentation. This is part one of a three-part series looking at footbridge dynamics with lusas. In this session we're going to define the basic lusas model that's going to be used for the dynamic checks. I'm going to create a new model called footbridge model. I'm going to work in the units Newton meters. This is important for the code checks we're going to do later on, and Z is going to be my vertical axis. I'm going to click in the Y box just to look down the Y axis, and then I'm going to look at the engineering drawings that we're going to be working with. The half elevation is 15 meters, so the full span will be 30 meters. The bottom chord has a radius of 199.7, top chord 28.9. So in lusas, I'm going to start by putting some points in. The start of the line will be at -15, 0, 0. The end of the line will be at 15, 0, 0. And I'm going to put a third point in at 0, 0, 15. These are the points that I have created. And I'm going to select them in the order that I created them. That one, this one, and finally this one. If I go to the line dialog and click on the down arrow, I can go to arc, and these are the point coordinates for the selected points. I'm going to select the middle one, and this allows me to put a radius in of 199.7. The curve will bend towards that point there. I'm going to hit apply, and then I'm going to change the radius to be 28.9 and click OK. I can then delete the construction point up here. Okay, if I look back at the drawings, we have transverse members at 3 and 4 meters and one here at the ends at 0.6. So I'm going to take this point and copy by 3 meters in the X direction. Take the new point, copy it by 4 meters 6 times. I'm going to take this very end point and copy in the X direction by 0.6. I'm going to take this end and copy by -0.6. I'm now going to select all the new points that I've created, and I'm going to sweep them to create lines in the Z direction. So I'm going to sweep by 10 meters. 10 meters isn't important, I just want to create lines that cut through the bottom and top chords. I'm going to do a crossing selection to select these lines and the top chord, and I'm going to go to geometry point by intersection, and this allows me to split those lines. I'm going to hold the T key down on the keyboard to do vertical selection only and select those lines which I'm going to delete. I'm now going to hold the T key down again to select all these lines, hold the Shift key down, click on the bottom line to add that to the selection, and I'm going to split them again. I can now delete the parts of the lines that I don't want, so I'm going to hold the T key down, select this line, all of these point lines along here, and the end line here. And I can then delete all of these lines, and I'm left with the points along the bottom chord. Okay, I now want to select these points and sweep them transversely across my model. Now if I go back to the drawing, the two trusses are 4.1 meters apart, so I'm going to sweep them in the Y direction by 4.1 meters. I can then rotate the model around and select the first truss and copy that in the Y direction by 4.1 to create the second truss. So this is the basic geometry we're working with today. I can now start to consider the engineering properties. Now if we look at the attributes menu, every model needs the top 5, and I'm going to start with mesh, line. I'm going to use the element thick beam, and I'm going to look at 3-dimensional. I'm going to give it the name thick beam. If I OK this, it appears in the tree view. I'm going to select the model and then drop that onto the screen. Now the geometric sections that we're going to use are in the section library. And we're going to use some EU sections today. Now the first section for the top chord is going to be a pipe section, and the section I'm going to use is a 273 by 20. Once I've selected it, I'm going to hit OK, apply. I'm going to delete this name, and then I can change to a smaller pipe section to be used for the hangers. This is a 114 by 10. Apply. Now the deck section is formed from HE sections, and the section we're using is a 280A. Hit apply. I'm going to then swap by 90 degrees because I need two orientations of this section in the model. Now I'm going to look side onto the model, so I'm going to click in the Y box, and I'm going to cross through the top chord and the hangers, and I'm going to drop on the large pipe section. Now I'm now going to reselect the hangers by crossing through them, and I'm going to drop on the smaller pipe section. In lusas, if you drop a geometric section onto a line that already has one, it over-assigns it. You don't have to de-assign it first. We're now going to assign the deck section with the HE section. So I'm going to select all the lines in the deck and drag on the first HE section that I created. Now if I look at the isometric view and zoom in, you'll see the transverse members have the right orientation, but the bottom chord doesn't. So I'm going to look down the structure again, and I'm going to select the lines of the bottom chord, and I'm going to drop on the fourth geometric section. I'm going to look at my isometric view, zoom in a bit, and have a look at the orientations. So the orientation now is correct. Okay, I can finish this model off. Materials, material library. I'm going to use an EU steel. I'm going to select everything and drop that steel section onto the model. Now the supports, I'm going to have one abutment as pinned, fix X, Y, Z. I'm going to hit apply, and then I'm going to free the X direction. So this is going to be a roller, a free to slide in the X direction. I'm going to switch off my fleshing, and I'm going to pick these 2 points and drop on the pin support. I'm going to select these 2 points, drop on the roller support. I'll switch back on the fleshing, and I can start to put some loading on this model. Now I'm going to go to load case 1, right hand mouse button, switch on gravity. I'm going to then rename load case 1 to be self weight, or SW, and I'm also going to rename analysis 1 to be analysis 1 linear static. I can then rotate the model around a little bit, and I'm going to save it and then solve it. And you can see I've got a deformed mesh on the screen. If I go to the layers, I can switch on my window summary, and I'm getting a deflection of 4.1 E-3. So in terms of millimeters, that's a 4 millimeter movement. Now if I was designing this footbridge, I would go on and do the other static loading, but what we're going to do now is progress to modal dynamics. Thank you for your time, and look at the website for further information and the other parts of this presentation.